Okay, it's 8 o'clock. We'll get started. Okay, I already sent out a notice for other students, so we'll get started. Today we are going to cover the chapter 5, generic programming, and this one is the last chapter. This one is the last chapter, the very last chapter for OOP, for object-oriented programming. Okay, that's last chapter. So far we covered the class design. That's one chapter. And then we cover the inheritance, polymorphism, object class, and interfaces. And today we are going to talk about generic programming. And that is the last chapter for, for the OOP. And after you learn OOP, next one, you can go to the graphic user interface to design the game. Or you can go to competitive programming, because you already learned the OOP, then you can learn the data collection, data structure, those kind of things. So this is a gateway to more advanced programming. Either you go to the game design or you go to the competitive programming user code, you need this OOP. So that's why we put this 5 chapter at the beginning part of this AP Campsite B, okay? Okay, anyway, and then today's topic is generic programming. That's the last chapter. So first, we would like to talk about what is generic programming and why there is a generic programming, and then generic basic, and then how to design the generics. So first thing is like we want to know about what is generic programming. Okay, generic programming is a need starting from when you have an OOP, you have a OOP, so you have rectangle, you have oval, you have square, you have prism, you have different classes. You also have oval. Okay, so sometimes you want to process the data across these different types, not going to fix on certain types. So you need to have the generic programming. Generic means general, right? General. So you want to have a programming paradigm that can do across different data types, not just one data types. That's the original purpose of generic programming. Okay, so then we have generic programming, we have object-oriented programming, we have object-related programming, and functional programming. These are all generic. And then the underline is imperative programming. Imperative programming means you are using Van-Neumann machine. Okay, Van-Neumann machine. Van-Neumann machine is a machine using memory, using CPU. If you use the CPU, use memory, that's called Van-Neumann machine. So most of the program that you see so far is imperative programming, okay, because you use a CPU and memory. But nowadays we do hear the word GPU, and we hear the word TPU. So these are not CPU, these are not Van-Neumann machines. So they are neural network based. They are systolic array based. They are not the regular CPU. So basically, these AI stuff, the GPU, TPU stuff, they are not imperative programming. They need to use the functional programming. They need to use OOP. They use different technology to solve it. So they are different programming paradigm. So Van-Neumann machine is one paradigm. Neural network is another paradigm. Fuzzy logic is another paradigm. Quantum computing is another paradigm. So there are many, many different paradigms. And as a computer scientist, you need to be able to program on these different paradigms. So going back to here, the first few chapters of the APCSA, we are on imperative programming. And then APCSB, we start to talk about this object-oriented programming. So these are two paradigms already. So now we actually moved on to generic programming and functional programming. So this generic programming is available after Java 5. So before Java 5, there's no generic programming. There's OOP, but there's no generic programming. So then we go back to talk about the version of Java. Okay, so right here, this page is an AI page from the Google. And I search for the user code version for user code server for Java. So currently they are supporting Java 11. So that means if you use a Java 24, 26, this newer version, this feature is not supported. Okay, they are only on Java 11. So Java 11, I think is somewhere around 2011, maybe. Java 8 is released on 2008, and Java 11 is 2011. So after that, the user code server never changed. They keep using this Java 11 version until now. Maybe there's a newer version, but at this moment, what I see from internet is only Java 11. Is that okay? Hello?
Yeah.
So if I search in the internet and say that this feature is Java 24, should I use it? Yeah, you can use it for your own project. But if you go to AP exam, it is not supported. AP only tests you up to Java 8. So any newer feature, they don't support. And then if you are actually Java AP, if you are doing user code, it is supporting this Java 11. Okay, so you have to know which one are you using and which exam or competition you are on, and you need to know about their server and whether they support which version of the Java version. Okay, so that's one thing you need to know, that the language versions. Of course, we want to learn the newer features, but if the server doesn't support, then you cannot use it. Okay, you cannot use it. Okay, that's about the version of the language. Now let's go back. So here we actually talk about generic and imperative and functional programming. So the purpose of generic is to have a function or a container or a iterator that can process data of different types. So basically, they are generic programming, including generic container. So you have a list of T type. So the T, you can change different types. So type T is the type variable. You can change the type variable. So the container such as Q, stack, map, set, they are generic. They can handle different data type. So that's called generic container. Okay, another thing is the generic method. So you have a function that can deal with integer, string, integer, character, different data types. Then we call this function is a generic function. So there's a third type of the generic, not listed here. It's called generic iterator. So generic function, generic container, and generic iterators. Okay, generic iterator. Last time we talked about iterator. So iterator is a pointer pointing onto your object. Okay, we will talk about this more in C++ language, but Java, I don't think the iterator is very efficient. Okay, so we don't spend too much time on the iterator. But anyway, that's the third feature of the generic programming. Okay, then you want to, for example, one of the example is the generic function. I'm sorry. So for generic function, usually you can look at the sorting algorithm, and we would like to make the sorting algorithm available for generic data. Okay, so you may have a quick sort that can do sorting for all different data type, integer, double, any type. You can use it for sorting. Okay, so let's look at the generic functions. So first thing that you would like to learn is generic function. Let's get started for generic function. It's a little bit slow. I'm trying to create a new project, but it's not reacting. Let me redo it, okay? Sorry. Let me redo it. The version I'm using right now maybe is Java 24. So some of you guys program, if you are using the newer feature, I may not be able to compile it, okay? That's because that the version is too new to me, not compatible with my compiler. And because I installed this software maybe 4 years ago or something, 3 years ago, I don't remember which time I installed it. Wait, this one is too slow, actually. How come it's not reactive? No, I'm trying to create a new project. Okay, sorry. So I'm using the older version, not the newest one, but because that I do not update my Java virtual machine every year. Okay. Okay, anyway, let's create a generic maximum. So let's do generic max. So this is a class. Now we want to do generic function. So to create a generic function, you have a public static. Okay, then you do T type. T type specify if this function is generic. T is not a return type. This actually T is the type variable you would like to associate with the function. So the return type is T. Okay, this is return type. The previous one is the denotation for the type variable. Okay, after that, you put your maximum function and put your T array there. Let's assume it's A. I'm sorry. No, that's actually put A and B. Okay, two variable, both are T type. Okay, then you have these two variable, and then you do this, and then you do if A compare to B greater than 0, you will return A Okay. However, you return B. Right here, this T type, it actually do not have a comparative. So right here, we need to say this is a type that extends comparable. Okay, usually interface is using the implement. But in generic programming right here, you specify as the extent. Okay, here it actually really means implement. The T must implement the comparable. So this one, in order to make it work, the generic type variable here must extend the comparables. That means that they have the compare-to function to use. Then you can compare the maximum for the for this maximum. Okay, so let's do it this way. Now with that, you do public static void name. So you do what? You do integer a equals 3. I'm sorry, let's try different things. Let's try object. Okay, so this one we actually specify A variable as 3, B variable as 4, and then C is maximum of A and B. So apparently this maximum function, it will call this generic function, and it's the integer type, so T become integer. And integer do implement the comparable. So this one is okay. You return the bigger one for it. Anyway, that is a maximum. Now, if we do double T equals 3.4, then we do double E equal 5.6, then we do double F equals maximum of B and E, then we do system that out the clean line of your F. Compile no error because the function now is generic, so it can be actually it can be used to handle both the integer type and the double type. This is called generic programming. Any questions so far?
No.
So this is how you do the generic. The only difference is that this portion is the same. You have integer, maximum, integer A, integer B. This is the original function. Now you change this one type to T, to T, to T. These are the same. The only difference is that before your return value and the static, you put your type variable specification, telling people that this T is a type that extend the comparable. And this extend really mean implementation, okay, implements. In generic programming, we use extend. We don't, right here, we use extend. We don't use implement. It means the same thing, okay? Okay, so this is the way you write a generic function. Let's try another one. So let's assume that you actually, let's do selection sort. So segmental, because you are also implementing, you are actually processing the data that not must use the compare to function. So here you also use the extends comparable. Okay, so that is not return type. This one actually usually I write it right after the static like this, saying that this is a static function with the process on type variable t. Return type I call it void, and then this one is selection sort. And then we pass a array into here, so that's actually pass a t type array. A, okay, so there is a t type array A. Because we are going to demonstrate array, so maybe later we'll need to use Java that util that arrays, okay, prepare that. Now we got this array A, we are going to do sorting on it, so we will do selection sort. So selection sort, let me do it one more time. You need to remember the algorithm is starting from here, the to be swapped location is 0 until -2, because the last one, there's nobody need to swap with it, okay? So basically, this one is to be swap location, and you find the minimum to swap with it. Okay, that's the algorithm. So the outer loop is to look at the to be swap location. You must remember it, okay? Here I'm demonstrating it how to do it. But you must remember it. This is the outer loop. Outer loop is to be swap location. You don't need to remember all the code, but you need to remember the idea, okay? So the idea is that you need to, outer loop is the to be swapped location. So that location to be swapped. So here you do have an integer, here let's do index equals I, okay? That's also where your minimum is, okay? So you can keep track of the minimum, or you don't want to do the minimum, that's actually fine, okay? That's actually fine. Then let's do this, let's do, you start to do from integer j equals I plus 1, j less than a length, you go to the rest of the array, j increase to see if which one is the maximum. So that's if, I'm sorry, the minimum, okay? So if a j that compare to a's index is less than 0, is smaller than that minimum, then index equals j. Okay, that's actually this one, you get the minimum index. I'm writing different version, okay? Sometimes I use the minimum value, but here I don't want to use the minimum value. I just use the index. Okay, I just use index. So you found that. And then if I not equals index, then we need to swap. If we need to do swap, then we need to have a t that's temp type. The temporal value is t type, will be equal to a I, and then is I'm sorry, a I will be equals a index, and then a index will be equals temp. Okay, so that is the selection sort, and we don't want to return anything. So this one is a destructive program. It will change the content for the array, but we do not need to return it. The data already been sorted, okay? So now right here, we want to demonstrate it. Here I'm missing the E, okay, missing the E, it's okay. Now here I want to have a static integer array. AX equals, let's do 2, 5, A 4, 1, 1, 10, okay, whatever. Let's do another one. That's actually static. Okay, double array bx equals. Here I'm just trying to demonstrate a feature, so I don't care about the value. Okay, that's not a big issue. Okay, anyway, we got the data done. Now we are going to do sorting for them. So public static void names and then string level bracket args. And then we do selection sort on AS, and then we do system.out.clean line arrays .toString of the AS and selection sort of BX and then system.out.clean line arrays .toString of DX. So right here, what I want to tell you is that why I need you to memorize the selection sort, bubble sort, all kind of sorting. That's because that you need them. When you need them, you need to be able to write them right away. You cannot say, oh, I will forget it. I need to check where something else. Then that's not good enough, okay? That's not good enough. As a coder, as a programmer, you need to have that. So the data got sorted. Any questions so far? So this one is a generic sorting algorithm. We can keep doing that for all of the bubble sort, whatever sort, quick sort, merge sort, whatever sort you want to have, okay? But right here, we are not teaching you the sorting algorithm. We already did that in the previous chapter. So I just use the selection sort to tell you what is generic sorting. Generic sorting means a sorting algorithm that can provide service for different key type variable. You give an array of key type, then that should do. Okay? Any questions so far? Any questions so far? Now, okay, this actually is having the generic programming, you have a T type. If you do not have a T type, then what kind of generic function we can do without a generic T? Okay, if in the old day, there is no T, we can only using inclusion polymorphism. So it's impossible that you use that. Then you do public static. Okay, let's assume that you actually return object type. And you have maximum function, you deal with object A and object B. Okay. This one has a big problem because object type cannot have the greater than operator. So this type of a generic algorithm, even you want to use object, it doesn't go through. Okay, it doesn't go. So this one doesn't work. Then you need to change it. Let's assume that you change it to number. Then your object becomes smaller scope. So basically, under the small scope, it is supporting the compare to function or supporting the greater than function. That is okay. So this one's still not okay. You use number is still not okay. Let's try difference. Let's try the compare to. You're not okay. Number doesn't support it compared to SQL. So something like that, you actually cannot make your generic function work. Even using the inclusion you cannot do that. But let's try another one. Let's try public static, okay, void include. And then here let's use an object type. This one I think okay because printing, there's no limitation of what it should be printed. Comparison, greater less than, you do have what is supporting the greater than or not. So this one, okay. This one, any data type can be passed over there. Okay, so a double or a integer, they both pass as an object, and then you can reprint it. There's no problem, but there's no problem, but your generic function, say your type, using the object type, object's function is limited. Object's function is very limited. So in a way, you want to make a generic algorithm, then you need to build a different OOP structure so that the type can include the function that you need. Then that is not really efficient. That's not really efficient. Okay, that's not really efficient. So after Java 5, they think that this object inclusion polymorphism is not efficient. So they start to use the type variable T for generic algorithm. Okay. Any questions so far? Any questions so far?
No.
No. So this one
No.
is this one already been given up. So people start to use the type T. Okay, this one is better, and then we can do sorting. Now next one we are going to talk about generic container. So generic function we know it already. Generic container is not hard. It just you specify the data. Let's try let's see. Let me search the internet. Maybe they have code already. Okay, let's try. Let's call Java generic array. So the Java generic array, you want to create an array that actually is T type, and you create a object. Then this constructor, you create a object type, okay. And then later your element, you assign T for it. When you get, you return T type. So this is one way to handle it using the T type. But this one is not a perfect one. There is another way to do it, better way to do it. Okay, but let's try this one first. Okay, let's try this one first. This one is using a hidden object type and then conversion to T type when you need it. Okay, when you need it. There's another way that you may use a generic container T, and then you hidden a list of T, and that guy already has a T variable that you can use it. Okay, that's another way to do it. This actually is still not the best way to do generic array. There are still third way to do generic array. There's different way to do generic array. Let me see. Okay, anyway, too much. Let's just do it one by one. Okay, so that's first one is generic array one. Okay, let's do generic array one. Let's don't call it generic array one. Let's just call it generic array. So this is a generic array. Want to implement want to actually have the T type, so you need to specify the T. So it's a generic of the T type. Your data is generic array, but you implement the data type of the array is T type. So you need to specify the T after the class name right there. Okay. Now you need to put your data inside. So your data inside because you do not know what type of data it is. So but you want it to be an object type. So let's do private object array data. Okay. And then let's do generic array integer n. Okay. And then your data equals new object of the n generic. I spelled it wrong. Okay, generic array. Then let's do get function. Okay, let's do get function. Then you need to have a get function, set function, and get function. Okay. The get function here, it has a notation of the suppressing warning. So this one, it doesn't check the range of your index. So you may have the array index out of bound problem, but this one specify the compiler saying that we don't want to check. So suppressing the warning unchecked. Okay. So this one, it will return the data of the index, return the T type. Then you also would have a public, okay, void set function. You set integer index with the T value. Okay, and then your data's index value should be equal to value. This is your set function. Okay. Okay, we got a get and set. Now next one, we want to do toString. So public string, toString. So you have an object type string. Then you want to actually you want to do return. Okay, array the toString of your data. Okay. And then you do not have the arrays, so you need to import java.util.start. That's it. That's your generic array. Now we got a generic array T. Okay, so let's do this. Let's create it. Let's actually do test generic array. So you create a generic array. A equals new generic array. of 3. Okay. So A has 3 elements. So A does set 0, 1. A does set 1 or 2. Okay. A does set 2 is 3. Okay. Consistent about that 3 line. Okay. Right here, this one is a generic array. We forget to put the type. So this one keep the type T into the class. Okay, put the type T into the class. Okay, so 1, 2, 3 being printed. Any questions so far? It's created a generic array type. Any questions so far?
No.
So generic array or generic dynamic array, generic whatever, it will help you to understand how to create a array of generic type. Okay, that we call it container. But right here in the core, it actually hidden an object type. So this one is the old-fashioned way of doing generic programming. There is a way that you can directly specify the type for it. Okay, let me check for my older version of the data. Let me see. Do I have the code? No, let me try. Okay, maybe, maybe not. I do have the code before. Generic dynamic array. Okay, one moment. Let's look at the generic dynamic array. Okay, these are generic object, generic metric, generic array key. Let's look at this generic array key. Okay, so this one is a generic array key, but this T is different from the previous one. It really allows you to put a key type right here, and your data is stored as T type instead of using object type and convert. Okay, so you do have the T type. And then you actually, when you start an object, you can use a integer T and then load it into the generic array. This is a different way to do it. Is that okay so far?
Yeah.
So this is a different way. I don't want to redo this one, but just showing you that there is a different way that you can do it with a generic array, okay? Generic array. Let's see, let me see if there is other generic stack. Let's look at this generic stack. So here is a step that actually taking the E type there. And you can push pop the E type data, and then you can do it. This is generic already step, okay? We will do this later, okay? This one is beyond what we are doing right now. Okay, let's go back to the slides. Let's don't jump too far away. So right here, we do give you a generic array of T type using the hidden object type. But you can change this one to T, and then you can load the T type to the array. Okay, that's one way that you can do it. Now let's continue the slices. So in a way, it is a generic programming. We also call it parametric polymorphism. Okay, it's also called this generic programming, also called parametric polymorphism. It's using generics. The iterator one, we are not going to cover it right now. Okay, it's actually too far away. Okay, I'm not going to do this simple part. So you can use an object type to do generic programming, but that's already old method, old-fashioned way. Okay, let's continue. So there's a type variable. Type variable sometimes using E or using T, that's either way. E as entity, T as type. Okay. So either one. So sometimes also maybe N for numbers. So these are the convention that usually people use a NT or E. Okay, right here, so far, these are okay, generic method, generic container, we cover it. Next one is the bounded generic type, okay. Bounded generic type because that sometimes your T is not every T. For example, that E maybe sometimes just do sorting, so you need to extend comparable. Only which the object that is comparable can be used for the object. So that is bounded. We call it bounded. Bounded means that there's a qualification for the object type. Not every type can be put into the generic. Okay, so it's a bounded type. So usually comparable is one thing that you would like to use, making sure that your data have the comparative function. Okay. Row type, we use an object, then we call it a row type. Okay, this one is old, so we don't spend too much time on row object. And then there are wildcard generic type, unbounded or bounded. So that is so you can use the question mark. So question mark is unbounded wildcard, which is the same as question mark extend object. So question mark extend T. This means that anything that extend T. So you may have a generic step. So everything extend numbers. Okay, so it's not a number. This one, it can be any type, such as integer or double, that it extends numbers, then it can be put over here. Okay? It's called unbounded wildcard. But this is seldom being used, so we don't spend too much time on this, okay? This is just creating confusion. So you have integer, then you have type variable T to map to the integer. Then you have already some integer that's T type T map with integer. Then you may have array data type of with the unbounded variable question mark. You generalize that question mark. And then you have already of question mark extend T. You can have any type that's under T or any type that above T. Super T means above T. So for example, you have class that you specify as T class. So question mark extend T is any of the subtype under T is using question mark extend T. Okay. Question mark super T is anyone who actually super T on top of T. Is that okay so far? Hello.
Yeah.
这样 is that okay so far?
Yeah.
Make sure you understand this, okay? We don't spend too much time on this because these are seldomly used. But just give you the idea of how you can specify the wildcards to later, okay? And then you can build a hierarchy to check whether it's a super, it's an uppercase, or extend the lower hierarchy for the wildcard. So this one is simple, but we do not spend too much time on this. We are going to move on to something else, okay? We are going to move on to something else. We don't spend time on these things. Right now, this become not as important as before. So you may have a metric of double type, you may have a metric of rational data type, you may have a metric of numbers. So the metric may also be a generic metric. Okay, it's okay. We don't repeat on this one. You can check the internet for the programs. This one, generic iterator. Generic iterator means that you can create an iterator that can be specified with different type. And iterator is a pointer. Okay, so anyway, this one, I think we don't want to spend too much time on this. Let's try to look at something else, okay? Something else that I want to discuss today related to generic programming, and more important right now is not this kind of the super complicated generic, okay? We don't spend time on those things now. Today I'm going to talk about functions, functional programming. Because functional programming is related to a few things, related to AI, related to machine learning, related to calculus, related to optimization, also related to recursion. So it's very important, but it's also related to generic programming, okay? That's called functional programming. So that's what we want to discuss today. So before we do that, I'm going to create a new directory. I'm not going to use the same one. It's actually a different one. Let's create another one. That's called chapter 5. Underline function, no. Okay, let's do it here. Before we do this functional programming, okay, let me bring up the idle for Python. I'm going to show you what is functional programming, okay? And before we go into the functional programming in Java. So first thing, I'm going to create a new program. This one is a Python program. So let's define a function that's called f function. That's called add function. The color is not good. Let me change the color. Let's use the classic. Okay, don't use the dark one. Okay, so f function. So here let's do x function. Okay, so in Python, it is allowed to define a g function of the y, and then you do return x plus y, and right here return g. Okay. So anybody know what this function is? There is a function inside the function. and you return that function. So can anyone understand this function right now? What kind of function it is? Harrison, are you okay?
Yeah.
What this one for?
What do you mean?
So what's the purpose of writing this function?
Return x plus y.
No, it doesn't return x plus y.
Uh,
It returns g.
Wait, doesn't that return x plus y?
No. How about Kirsten? Can you understand this function? Hello? Hi, Kirsten, do you hear me? Oh, he's not even here. How about Jiang? Jiang, are you here?
I think it returns a function
Hmm?
where x is. I think it returns a function where x is 5.
A function that returns x plus y, yeah, that's correct. But how to look at this function is you do have a function that's called add function. You get the input of x. Your output is called g function. So you input value, output function. This is called functional programming. Okay. So what it is that traditional function is that your f of x, you enter x, you return x squared. It kind of enter value, you return value. This is called traditional function. This is called traditional function. This is imperative programming. You have x, you process x, you get a result. Harrison, is okay?
Yeah.
But this one, functional programming, is different. Functional programming, you can put the x into there, but your output is a function. So you put the value in, you return a function. Or you put a function in, you return another function. Or you put a function in, you return a value. Or you put a value in, you return a value. So it can be function input, can be value input, can be function value, both input. Can output function, can output value, can output everything. This kind of programming, we call it functional programming. Is that okay so far?
Yeah.
Okay, this is called functional programming. So let's look at how to use this function then. Let's actually do this. Let's look at how to use this function. So let's do add2 equals add2. Okay, so this one, let's see. Kingston, you are back where you are. So Kingston, what is this one do? Add2 equals add of 2. Hi, Kingston, are you there? Can you speak or no? Oh, you cannot speak. Okay. Anyway, this one, you actually create a function to add2 to input. So that create you enter a 2, and then you create a function that will add 2. So this add 2 is a function. So let's assume that you actually do g equals add 2 of 3. That means there is a function called add 2. And this add 2 function is created by add function. Add function enter 2, create a function called add 2, and then this add 2 take an input of 3, and it should create 5. That's the output you get. So in a way, add function is a function that takes a value, output a function. Let me put into the directory that we have, okay? Okay, I call this one add2.py. Anyway, this one, let's actually run it, and you get 5, okay? That's the result. So basically, functional programming is that you can take the value of function, process it, and create a new function that's called functional programming. Okay. And then there's a question of who will use the functional programming. That's one question we have. Second question is, can Java do functional programming? Answer number 2 is no. Java just partly not the best language to do functional programming. So it actually, in AI age, Java is fading away because it doesn't support the functional programming to the best way. But they do have some other new language on top of Java virtual machine to do that. But Java generic language does not support functional programming that way. So this one is like that. Second, who will use the functional programming? This is more important. All AI is doing it, all calculus is doing it. So let's look at the calculus. I don't know how many of you know this one, but this is who already taken the calculus? Anyone? Jiang, you understand calculus or no?
I don't know well about it, but I know a little bit.
How about Kingston? Do you know it? No? Okay. Okay, anyway, why am I talking about this? That's because that this one, you have a function of x squared. You take the derivative point, you are finding the slope for the f of x, and it's equals to 2x. This one actually is, you do have an input of the f function. You take derivative, so derivative itself is a functional programming. You output its derivative. This is another function. So input function, output function, that's called functional programming. In any, this one is differentiate, finding the derivative. So finding the derivative and finding the integral calculus, both are functional programming. That's why if you want to learn AI, you need that calculus. Is that okay so far?
Yeah.
Okay. Okay, so that's the idea. But again, this one in Python, it requires function inside function. And Java do not support it. Okay. Java do not support it. JavaScript support it. Python support it. But Java do not support it. So this one in Python, in Java, there's no way you can create a similar situation for it. No. But we do have workaround methods. We do have workaround methods. Okay. This one's called okay, let's do it. So this one is a Python, but we do not support it in Java. So let's look at Java. Java, we call it functional closure. Okay, let's do it later. Okay, this one, let's check the example. That's actually too much. Okay, right now let's actually create an interface. Let's create an interface. This interface, let's call it functional. So there is an interface that we teach you what is interface before. So let's assume that we have a function, an interface called functional, and this functional has only one function that would do public double call double X. So this one is a abstract function, abstract method. Okay, you input a function, a data X, and then you return some value of a double type. Okay, that's called functional. And how can you use this functional? Okay, let's do it here. So now let's create another one. Let's actually create a add. Okay, let's create add. So this add right here, that's actually let's see. This add function, that's actually to implement the functional. So add implement functional. So add must have a call function. Okay, add must has a call function. So right here, let's do this. Let's do integers. No, don't call it X. Let's call it Y. Okay, let's call it Y. So add integer Y. Okay, and then this dot Y equals 1. Okay. And then we need to implement a function also. We need to do public, okay, double equal X. And then this one will return X plus Y. Oh, this double. I'm sorry. This is double. Let's change it. I'm sorry. Let me change everything to double. I don't want to create trouble. Okay, let's change to double. Okay, so this one is a X class, the implement functional. Okay. So let's see. So let's create test it. Now we create at2 equals new at of 2. So we create at itself is a functional, and at2 will put the y as 2 into the function. So when you call it, any variable will be added with 2. So this at2 will become a function that will do at2. Now let's do system.out read line of the at2 with 3. Oh, I'm sorry. at2 that call 3, not at2 3, at2 that call 3. at2 is a functional. at2 do have a call function. This is called functional closure. And in a way, this interface plus at class plus test X class, this is the same as the Python's functional programming. Is that okay so far? Is that okay so far? Harrison, are you okay so far?
Yeah.
Let me bring up this Python code again. So this Python code, we do have this f function. You input the x value, then your function become add that value, at2 function. So at2 function, you add with 3, that become 5. Okay, so this one is what it is right here. And the same function, when I go to my my Java to do it, then a little bit more wordy. So you can see that Python is a better language in functional programming. But we can create a functional interface. You can provide a call function. So this call function is just like you return a function, but there is no return value of the function type. So you use the interface. So now you actually create a class that implement the function. So this one do have a call function. And then since it's the call function, so you can directly use call to call 3. So this one effectively is creating the at2 class, but that class actually contains a function. So it's actually a function that being programmed to at2. And then that function called 3. So this one we call it functional closure. And it is in a way to implement a functional programming in Java. It's a workaround way, but not a perfect way. So in terms of AI and functional programming, Python, PyTorch, Python TensorFlow is a better tool set compared to Java. Is that okay so far?
Yeah.
Okay. But this doesn't mean that Java is useless. Doesn't mean that, okay? We show you this, we are going to give you the idea of how this functional is going to be useful. So let's do this. Let's actually do another one. Here we have f function, impermanent functional. So let's do another one. Let's actually do calculus. I create a class called calculus. So this class called calculus let's pass a function f into there, and then with a double of the x, and we are trying to find the derivative of the f. So this one is we intended to pass f of x into it, and we'll do d f of x dx, and the return value will be this one. So that's finding the derivative for this function. Okay, so we will need to have a constant final state double e equals 1e minus 9. It's a very small, tiny value called e. Let's call it h. Okay, don't call it e, let's call it h. Okay. So I pass a function f into here, and then with the x, so this x limited h approaching 0 for h f of x plus h minus f of x. This is derivative. This one should df dx is the slope of the f function. And this is called derivative. Is that okay so far? Hello, is that okay so far?
Yeah.
Any question? It is okay if you don't know calculus, but if you want to, this one is to find a derivative. Okay, let's actually try to use this derivative, okay? Let's try to use this derivative. This is a processing in calculus class, impermanent functional. Let's actually create another one. Let me use the example. So here, let's do this. Let's do test calculus. Now I need another one. Let's do linear. Okay, linear function. So let's do linear function. So this linear function, let me have a linear function. So this linear function implements functional. When you do call, let's do public double call double x you will return, okay, a times x plus b. So let's do public, let's do double A double B equals 0.0, and then linear double A double B, and then which that A equals A, this that B equals B. So this one is a linear function. This linear function is y equals f of x equals ax plus b. So b is the y-intercept. A is the slope. Is that okay? This is the algebra one, right? Is that okay?
Yeah.
So now we are going to do this linear function and then do derivative for it in the calculus. So this one is linear, and then we are going to test the calculus. Let's do test calculus. So right here, let's do public statement string that right bracket ARTS. Here, let's do this one is linear. Line 1 equals new linear of 1, 0. 1, 0 is what? 1, 0 is y equals x because b equals 0. Is that okay? Hello, is that okay?
Yeah.
Okay, now let's do this. Let's do double theta t equals new double. No, let's do double. Let's call it x then. Okay, so that's for double, okay, x equals 0.0, okay, x less than 1.0. Let's do less than equal to 1.0, okay. So then x plus equals 0.01. So totally you add 100s, and totally you come from 0.0 up to 1.0. So they are totally, oh no, this is not x. Let's do t right here. Okay. Totally 1.101 points. Totally 101 points. So your x of the no, this is not okay. Let's don't do it this way. Let's do integer I equal 0, I less than 1 x the length. I increase. Okay, so xi will be equal to 0.0 plus 0.01 times I. Okay. So basically, this one create a series of from 0.0, 0.01, 0.02 up to 1.00. Okay, so 101 point for the x. Now we are going to create y. Okay, so double array y equals new double, this one also 101 point. Okay, then for integer I equals 0, I then y the length, y in high increase. Okay, so y's I would be equals calculus that differentiate the derivative of taking derivative of what? It's called in line 1. Calculus is derivative, okay? So right here we are passing line 1 with the xi to it. Okay? There's no derivative. Finna refers to non-static. So this one is change it to static, okay? This one is change it to static. Okay, anyway. Then let's do this. Let's do system that out the green line of your xi plus comma yi. Okay, so you print s comma yi out. That's wrong. So because the slope is always 1, so it's very close to 1, okay? Very close to 1 for everyone, because you have y equals x and take derivative y prime equals 1. So it's a constant 1, okay? It's actually constant 1. So anyway, this linear function being okay to, you get a linear function's derivative. Okay, so with that, that's actually, let's just look at it here, okay? So now, got the data, let's see. No, not this one. That's wrong, one more time. So got the data right here that I'm going to do save to file. This one, let me put into the chapter 5 functional. I'm going to save it as linear, let's call it line 1 that XSL C common separate value file, CSV. Okay. Okay, one more time. Let me do it this way. So before we do this, let's do one more thing. Let's do system that out the green line of x comma y. Okay, we want this to be also printed to the file. So let's save. And let's run it one more time. And then let's save it to the file. So this one is saved to line 1 CSV file, replace it. Okay, overwrite. Now we got it. So we go to the file. And then we open it in Excel. Okay, now let's do it this way. Let's select everything. There's 101 points, so I'm going to select everything. Select everything, and I'm going to insert. Okay, I'm going to insert it, and then let's see, in a scatter file. I'm going to do line chart. So line chart give you the XY chart. So the original data is the blue one, and then the Y is slope. Its slope is keep at 1. Okay. Is that okay so far? Hello, is that okay so far?
Yeah.
Now let's do something else. Okay, this one is not the most fancy one. I just want to show you how to do calculus. I'm going to try another one. So this one, our function is linear. We don't want to do it linear. Let's do another one. Let's call it sine function. So we are going to do sine function. So this is sine functions. Sine function will also increment the functional. Okay, so sine function is, you do have a sine. So sine will be sine x. Okay, sometimes you have a frequency ft and then a for amplitude. Okay, so let's do it. Okay, let's do it. So here let's do double a equals 1.0. Double f equals 1.0. So no change, still sine x, but I just give you the frequency term and a amplitude term. Okay, so sine double a and then double f. Okay, so this dot a equals a, this dot f equals f. Okay, now I want to implement the co-function. So public, okay, double co of my double x. This one will return match the sign of f times x. Right here, a times this. So it's amplitude times frequency times x. Is that okay so far? That's a sine function. So d sine dx is what? Anybody know? Anybody know what is a d sine dx? Sine's derivative. It is cosine function, okay? It's cosine function anyway. So this one, it is the sine function. So we are going to put it into the functional programming. Let's do this test. Let's do another one. Let's do test sine. Okay, let's copy from test copies. Put into test sine. Okay, so right here we are creating a sine s equal new sine of 1, okay, frequency and amplitude both are 1. X101 point, no problem. Okay, X101 point also no problem. It's actually from 0 to 1.0. Okay. Let's see. Let's do. No, don't do up to 1. Let's do times messed up pi times 2. So up to 2 pi, 0 to 2 pi. Okay, let's do 0 to 2 pi for the x. And then we do cut derivative for all of the sine functions value. So here we change it to s. The same, no problem. That's okay. Now let's do this. We have the test sign. Let's actually run it. Okay, you've got a set of value. What it is, we don't know. We don't care. Let's actually save the file too. So we are going to do save to CSV. Okay. Let me do it one more time. Okay. Let's do save to file. Functional. So here let's just save to size CSV. Okay, finish that. Finish that. We've got a sine function. So let's look at here. Let's just select everyone. Select every data field. Then let's insert a line chart. It is not perfect, but it actually will be a sine function. Let's see, some of them are too small. Anyway, let me put it to be wider. Let's just select everything. Redo it again. Okay, anyway. What we want to say is that the chart is look like a sine wave. Okay, cosine wave. Not this one. This one's wrong. It is a cosine wave. Okay, let's see. line chart. Oh, okay, anyway. This one's just to show you that how to calculate the calculus for sine function, okay? I'll verify the data later, okay? But anyway, it create a chart, but I'm not sure this one. That's the chart. I think it's actually the XY may not be very perfect. Let's redo it one more time. Just select this, don't put the XY in there. Let's do one more time. I want the X versus Y, but it actually doesn't create that. It is X versus the index. It actually is X versus the index, okay? Anyway, we will look into the chart later, okay? Maybe using Python to plot the chart, but this one, from the data point of view, is really get the data of the cosine, okay? We really get that, so that's okay. Okay, anyway, what we want to say today is that we do show you what is functional programming, and then one of the way to do it is this derivative, and then you can find a derivative for another function, and you just specify the function as a function closure. So a function, a linear class implement functional, you can take the derivative from there. You can also use a sine function to do the derivative from there. So functional interface, even though it's only a interface, but you can use that for functional programming. Okay, we call it functional closure, because with this functional closure, you can pass your function into another function. Functional programming is not fully supported by Java, but by doing the functional closure, you can mimic the function of a Python language, okay, to do your functional programming. And these are the foundation of machine learning and calculus. Is that okay so far? Okay, we actually almost run out of time, so I don't want to go even deeper. We can do integral as well. But the integral part, you can start it by yourself, okay? So some other time, if we have time, we'll come back to do the integral. But right here, we do work on a single linear taking derivative. And also we're working on a sine wave taking derivative, okay? And that's using the function in the calculus. And function of the calculus is working because we had a functional interface. So this is also showing you another way to use a function, use the interface, okay? And that is very key in Java and C++ programming, okay? C++ also has no functional programming feature. They don't allow the function inside function, okay? It is not allowed. But C++ language can also do this functional closure, okay? Okay, that's it for today. Any questions so far?
No.
Okay. So we close the generic functional programming up to here. Next week, we are going to start the competitive programming. So next week, we may introduced was user code, what is comparative programming. Besides that, we will start the data collection. Okay, the second part of this course, the data collection, the set map, those kind of things. So next week we go to competitive programming. Okay, we get started. Things are getting harder and harder now. So number one, you must finish your coding back as soon as possible. Second, you must follow our instruction to do the homework that we have. Finish them because they will give you the foundation that you need to go into this data structure and functional programming and object-oriented programming. Third, you need to get ready to start to practice the coding back problem, code forest problem, hacker rank problem, leak code problem, the competitive programming. It's this time for you to get started. It will take you a lot of time to do it. Usually to pass user code, silver, bronze to silver, it is AP plus half a year to 1 year. Okay. Some people spend 2 years, that's possible. So it's AP plus maybe 1 to 2 years. So you are at the end of AP by starting to do the competitive programming. You need to work harder. Okay. Don't back up. You will not go in there. Any questions so far?
No.
Jiang, are you okay so far?
Yeah.
How about Harrison? Are you okay so far?
Yeah.
So this is where we are right now. Another thing is that you must be aggressive, okay? So don't just work on the assignment that we give you. That's not enough. You need to aggressive to study more things, okay? Study more things, making sure you are ready to handle the problems, okay? And the user code problem, you need to set up a schedule by yourself to train yourself, okay? Because we do not have the time to watch you do coding every time in the user code. Each problem will burn you 1 hour, 2 hours. So we really do not have the time to work with you in class. You have to work on it by yourself. And then you need to tell me what your progress is so far. And then let me know if you have questions. But you need to be aggressive by yourself. If you don't practice, nobody can help you, okay? Nobody can help you if you don't practice. Okay, that's it for today. Good night then. Bye-bye.
Thank you.
Thank you.
Bye-bye.